Hello everyone, welcome back to the channel. Today we are starting with a new series of the Tensor Processing Unit (TPU), which is a complete guide of the TPU. Here, the artificial intelligence and machine learning has transformed their technology in a past decade. At the heart of this transformation lies not just a software algorithm, but also specialized in hardware design to accelerate computation. While traditional CPU, that is central processing units, and GPU, that is graphical processing units, have been widely used for the AI workloads, the Google has introduced a class of processor in 2016 called Tensor Processing Unit, designed specifically for the deep learning task. The TPU represents the key leaf or lean of the domain of a domain that is application specific integrated circuit. Unlike the general purpose processes like TPU, the optimization of the mathematical operation must most commonly found in a natural neural network computation. Over the time, the TPU has become the core of the Google AI transforming infrastructure, powering products like Google Translate, Google Photos, Search, Gmail, and even the external cloud services. This article will explain you the TPU in details, their origin, their architecture, their difference in the CPU and GPU types, and their application with a feature potential. So the first question is, what is TPU? TPU is a tensor processing unit. It is a type of ASIC application specific integrated circuit which is developed by the Google to optimize the performance of the tensor calculations required in a deep learning and neural networks. The name tensor comes from this TensorFlow. The open source deep learning framework, and from the fundamental data structure tensor, it is used in a machine learning, which represent the multi-dimensional arrays. In simple terms, the CPU is like a general purpose worker that can be do many tasks. The GPU is like a specialized artist skilled in parallel graphics and numerical tasks. TPU is like a master craftsman, but solely for the AI and deep learning operations. Here's some historical background of the TPU. That is a pre-TPU era. That is before 2015, because TPU is invented in 2016. Here, the neural networks are usually trained and run on the CPU and GPU. GPUs are the originally designed for rendering the images, where the purpose of the deep learning, because of their ability to handle the parallel matrix operation. However, as a deep learning model grow larger and more complex, that is even a millions or even a billions of the parameters, GPU and CPU struggle with the efficiency and the cost of the power consumption. Here, the Google challenges Google realized that it is a service or search, translate photos, etc. requires billions of inference per day. Running those on the CPU or GPU that could be too expensive and power hungry. Here the solution is in 2016, the Google publicly announced a TPU version 1 V1 designed to accelerate the interfaces in a deep neural networks. TPU quickly becomes a part of the Google data centers, and where later it made available for the external developers through Google Cloud TPU services. Here, the why the TPU has created and why it is a motivation behind them. The motivation behind the TPU was the efficiency. The Google wants the higher faster performance for their AI workloads. It reduces the cost per inference. It lowers the energy consumptions as compared to the GPU. It gives the hardware tailor specifically for the tensor flow. This specialization made a TPU externally efficient for the matrix multiplication, the backbone of the neural networks calculations. The core architecture of the TPU is to understand and look at where the architecture is designed. The matrix multiplication unit, that is MXU. The MXU is the heart of the TPU. The neural networks heavily on the matrix multiplication. It multiplies the weight of the matrix with the input vectors. DPU version 1 had a 256 cross 256 systematic array that performed 65,536 multiply at add and add operation in a single cycle. This design is much faster than the GPU for this specific operation. The systematic array, the TPU uses systematic array to pass the data uh, uh, through the networks or the processes. This reduces the need of the memory access, which is often the slowest part of the completion. The higher bandwidth memory, later the TPU, like is version 2 and beyond that, it uses HBM to provide a high data transfer rates between the memory and the processes. This allows them to handle larger models with a faster training. Here the instruction set, unlike the CPU, which have complex instruction set, TPU have a simplified instruction set optimized for the linear algebra operations. Here in quantization support, TPU are the optimized for the reduced precision algorithms. For example, 8 bits integer instead of 32 bits floats, which speeds up the interfaces without such suffering suffering much more accuracy. And the next one, the TPU generation, it started from 2016. The version 1 of the TPU is coming and to the production line. Here, Google has released their several TPUs generation. Each one has have their improving the performance and the functionality. Here, the purpose of the interfaces is only for the training, not for training. It is just a, general use. It consumes 28 watts of power usage. It performs 92 tera operations per second. That it keep 92 T-flops data operations per second. It used for Google Translate and other services. Here in version 2, like in 2007, it is capable of both the training and inference. Here it uses HBM for the higher memory bandwidth. It gives a 45 teraflops of performance per chip. It is available in Google Cloud TPU. The here in version 3, it gives a larger and more powerful the liquid cooling introduced due to the higher heat challenge. It also increases the performance by 2 times, like 90 teraflops per chip. Here the TPU pods here the TPU pods are used. That is, it uses cluster of 1024 chips that deliver more than 100 plus petaflops in 1 second. The next version is version 4, which comes in 2021, which is twice as the fast of TPU version 3. It is more efficient because it consumes less power and gives you the more output. It uses the large scale AI models and GPT style LLMs for Google internal AI projects. Here, some of the applications of the TPU, like Google products. Google Cloud, TPU, research and their academia, healthcare, and autonomous systems. In Google products like Google Translate, Google Photos, Google Search, and their Gmails. Here it improves the real time translations, image recognition, and standardization, ranking or query understanding, smarter comparison, and spam detection. Here in Google Cloud, it's available for the developers like Google Cloud platform. It is gives the researcher and companies that sends the TPU pods to train the larger scale of the models. For the research and academics used for projects like a protein folding, that is DeepMind AlphaFold, uh, large language models like a Palam or Bird, uh, for the for and for medical healthcare like a medical imaging analysis, CT scans, MRI, drug discovery, that uses a deep learning method. The autonomous system like robotics and self-driving cars for inference at the scale. Here, the advantages of TPUs are the high performance. It optimizes for the tensor operations, giving the faster training and inference. It gives the high energy efficiency, lower the power consumption as compared to the GPU for the same workload. Scalability, TPU pods allows a massive distributed network, net distributed training. Integration with the TensorFlow, it is deeply optimized for Google's machine learning ecosystem. It is cost efficiency, especially in the cloud environment for the larger training jobs. Here it comes with some limitations of the TPU. That is, specialization in the TPU is not flexible for the GPU and CPU. Availability, most of the accesses are available in the Google Cloud, but is widely available in the GPU. Depending on the TensorFlow, best performance comes with the Google's ML framework, less optimized for the PyTorch. The cost of the TPU pods is very expensive. It is a it was for small scale developers. For the hardware access like a GPU, which can be by the personal uses, TPU are not available for standalone consumption of the hardware. Some of the features of the TPUs are the it is demanding. Yes, it is demanding, and it is specialization in AI hardware for continuous to grow. TPU are likely involved further for the several data directions like larger models, HTPU, better energy efficient, broader framework support, AI decarbonization. Here are some DPUs in the AI ecosystem. Currently, the NVIDIA has released the two widely used GPUs, that is A100 and H100, which are widely used for AI training. Here are some AMD GPUs that rising their competitors. Some of the graph code IPUs, that is intelligent processing unit. Uh, I will create a one video and on the IPU, that is intelligent. What is intelligent processing unit? So here the Apple environmental so created their some of the GPUs like neural engines for their iPads and iPhones. Here the Tesla is also coming into picture with the customized AI chips for their autonomous drivings. Let's come to the conclusion of the test TPU, that is tensor processing unit. This is a groundbreaking innovation for the world of the high of the AI hardware by focusing on the specific needs for the neural network, particularly the matrix multiplication. TPU is after much offered the unmatched performance and efficiency as compared to the traditional CPU and GPU for the deep learning tasks. From the powering the Google services to enable the cutting edge AI research, TPU have reshaped the landscape of the machine learning as the AI model continuously grow in a scale and complexity. TPU will remain at the forefront, providing the computation backbone needed for the next generation of the intelligent system. If you like this video, please like, share, and subscribe. Thank you very much for watching.